Welcome to my fourth quarter physics project, the physics of video games. I am Alex Brown, and I chose video games as my topic because they are heavily involved with high-level mathematics and sciences. I also enjoy playing them. In the future, I am considering becoming a video game programmer, or possibly even a video game engineer. This video highly relates to that goal of mine. I created this video entirely by myself using a PVR, which is a personal video recorder, Arcsoft Showbiz, which is editing software, and original footage of me playing video games. I received no help with my project. The first physics concept I want to talk about is projectile motion. I found this to be a very common factor in video games, anywhere from throwing a tomahawk to shooting a bow. These all fall in the category of a projectile because they all have a horizontal and or vertical velocity when they are thrown, or in other words, they have an initial velocity. However, the only force acting upon them is the force of gravity, which is a vertical force. It has an acceleration of negative 9.80 meters per second squared. In the case of these tomahawks, the tomahawk is thrown with an initial velocity, both horizontal and vertical. But the only force acting upon them is the force of gravity, which is acting downwards. That is why they make an arc through the air. Notice if I threw a tomahawk at 75 meters per second, some unlucky person is still going to be hit at full force with the velocity of the tomahawk of 75 meters per second. It's not going to slow down in a horizontal sense, only a vertical sense. My next physics concept in the world of gaming lies in electricity. To be specific, I'm talking about moving a charge from one location to another. In other words, I'm talking about potential distance. This is also known as voltage. In these first few clips, you are watching a guy lifting up a sword, which is electrically positive, into the sky. Lightning in the sky is electrically negative, so it obviously wants to reach equilibrium and disperse its electrons into the sword. So, when Link and or Demise lift their swords up into the air, lightning ionizes throughout the air and into their swords. However, the swords are not made purely out of metal. They act as capacitors and store charge. Also, the hilt of their swords are one heck of an insulator to keep their hearts intact. When Link and Demise slash their swords, the charge is released into the air and travels to their opponents, and then kills them, because the electricity goes throughout them and stops their hearts. It works because of this equation. Potential difference is equal to the electric field times its displacement, or distance between objects. Another physics concept I'd like to talk about is free fall motion, and you don't have to look hard to find free fall in video games. Just look for the guy falling to their deaths. In these clips, people are jumping to their deaths in the name of physics. The only force acting on them is the force of gravity. You're probably thinking that free fall and projectile motion are the same, but they surely are not. There are some distinct differences. The biggest of these lies in the fact that free fall only deals with vectors in one dimension. Simply put, when talking about objects in free fall, horizontal displacement and velocities are ignored. While watching these videos of people falling, you notice that there's a relation between an object's initial velocity and the time it takes to hit the ground. These factoids can be found by using kinematics equations. As you can see, these equations relate together 5 things: acceleration due to gravity, initial velocity, final velocity, displacement, and time. With just a few of these variables, you can solve for the distance an object falls, the speed of an object when it hits the ground. While watching these people dying, it should be noted that it isn't the jump that kills them. As I was once told, it isn't the fall that kills you, it's the rapid acceleration upon hitting the ground. The sonic boom is the next physics concept I'd like to talk about. It doesn't occur very often in video games, but it does in Call of Duty. Though we never specifically talked about what a sonic boom is in physics class, it was hinted at with the Doppler effect. Ask yourself this: if an object moves faster than 343 meters per second in the air, the speed of sound, what will we hear? Well, based on the Doppler effect equation, the person in front of the sonic boom will hear a frequency of infinity. You're probably thinking that it isn't dangerous since it happens all the time with aircraft. However, when someone is in a close proximity to a sonic boom, they can have some lethal side effects. In the case of the thunder gun, a part within the gun moves faster than the speed of sound while emitting the sound. This causes the creation of a sonic boom. and the zombies don't like this. The frequency is so high that it bursts their eardrums, therefore killing them because of blood loss. Plus, the energy given off from the gun throws them backwards a good distance. Alright, the last physics concept in video games that I'd like to talk to you about is microwaves. Or, more specifically, microwaves cooking an object. Now, we all know that microwaves work by making the hydrogen atoms in water rotate. The rotating kinetic energy keeps up with the water molecule and therefore heats up the food. In these zap guns, they work in the same way microwave ovens do, by using microwaves. In these guns, a beam of microwaves are shot through a converging or convex lens. The computer inside the gun automatically changes the size of the lens to change the size of the focal point, so the microwaves will all focus on the zombies. Now, since 70% of humans are made up of water, the zap guns are going to fry the zombies as if they are food. Though they are already dead, they will not be able to live when their brain and heart stops working, which is what it would do in the absence of H2O.
Sometimes I don't speak right, but then I know what
Thank you for watching my 4th quarter physics project. I had a lot of ups and downs with the editing software. This was my first time using it, but I hope you guys enjoyed it.